Last week, we reviewed the product of powers property and the quotient of powers property. Then you had 4 problems to do to demonstrate what you already knew. So just to review, the first thing we went over was the product of powers property with no coefficients. So we had the problem x to the 10th times x to the 4th. So what we did was use the product of powers property, and the product of powers property tells us that if our numbers have the same base, that we can add the exponents. Since our base numbers are both x, we were able to add our exponents together. So we would get x to the 10th plus 4, which equals x to the 14th power. Now you can visualize this problem by writing it out. When in doubt, write it out. So you could write out x times x times x 10 times and multiply that by x to the 4th power, which is x times x times x times x. Now if you count all of those x's, there are 14, which gives you an answer of x to the 14th power. We also did product of powers property with coefficients. So that was this example. This time we just used the product of powers property. So the problem was 2x to the 5th power times x to the 3rd times 4. The first thing you did was identify the coefficients. We have 2, 5, and 4. We want to put these in order. So we are going to separate our coefficients from our variables with exponents and put them first. 2 times 5 times 4 times x to the 5th times x to the 3rd. Let's simplify. 2 times 5 times 4. That equals 40. Now we can use our product of powers property to add our exponents 5 and 3. 40x to the 5th plus 3rd power equals 40x to the 8th power. You had to do 2 problems to practice the product of powers property. So let's go over those 2 examples. You had to do number 17 and number 18. Starting with number 17. The first thing you need to do is identify your coefficients. Coefficient, and hey, yeah, you have a coefficient here. It's a 1, so it can be invisible, but it's still there. So let's write our coefficients first. So this equals 3 times 1 times w to the -9 times w to the 4th power. Once you're to this point, we can simplify our coefficients. 3 times 1, that's 3. So we're going to bring down our 3, and now we are going to use the product of powers property to simplify our exponents. So we have w to the -9 and w to the 4, so that's going to become w to the -9th plus 4th power, which gives you a final answer of 3w to the -5th power. We need to come back to this problem when we review negative exponents, but for now, this is the answer that you should have. Number 18 is very similar. Number 18 also has coefficients. This time, there's no invisible ones. So we are going to rewrite 9 times 5 first, and then rewrite our variables with their coefficients second. So we took 9h to the negative second times 5h to the 10th and rewrote it as 9 times 5 times h to the negative second times h to the 10th power. Now we are going to simplify our coefficients. What is 9 times 5? Well, that is 45. Now you can use the product of powers property to simplify those exponents. So you will have times h to the negative second plus 10th, which equals 45h to the 8th power. 45h to the 8th power. This is your final answer. And because this is a positive exponent, we will not be revisiting this one. So you can put a star on number 18 because it is correct. The next thing we reviewed was the quotient of powers property, which tells us to subtract our exponents when they have the same base. So let's look at this first example. We have 12 to the 5th over 12. And we know any whole number is not just alone. It always has an exponent, even if it's invisible. So let's put that little 1 there so we remember it's there. Now, because our base number is 12, we are going to use 12 and then subtract our exponents. So we will get 12 to the 5 minus 1, which equals 12 to the 4th power. When in doubt, write it out. You can also write this problem out. There will be 5 12s in the numerator and 1 12 in the denominator. Cross out your pairs, and what are you left with? You are left with 12 times 12 times 12 times 12, which equals 12 to the 4th power. Our second example involves coefficients. So we have the problem 5y squared over 10y to the 5th. First, let's identify our fraction. 5 over 10. So we're going to separate our fraction from our variables and exponents. So I already identified that we need to simplify this fraction. And we know that 5 is divisible by 5 and 10 is divisible by 5. So if we do that, our fraction simplifies to 1/2. 5 over 10 equals 1/2. So we are just going to put those exponents and variables back. Now we can use the quotient of powers property. 1 times y to the 2nd minus 5th over 2 equals 1y to the negative 3rd over 2. Now you had to complete 2 examples to demonstrate your understanding of the quotient of powers property. The first one was number 24. So just like the example, Let's identify our fraction and rewrite the problem so we can simplify that fraction. So I'm going to write 30 over 34. I'm going to leave some space and I'm going to rewrite u to the negative 15 and times u to the negative 16. So let's think, what are 30 and 34 divisible by? They're both even numbers. They are divisible by 2. 30 divided by 2 is 15. 34 divided by 2 is 17. So your simplified fraction is 15 over 17. Now we can bring back u to the negative 15th and u to the negative 16th power. Now you're ready to use the quotient of powers property. We're going to rewrite 15 times u to the negative 15 minus negative 16, and that's all over 17. Now your last step is to simplify that subtraction problem with your exponents. Don't forget your integer rules. You're subtracting a negative number. Use your number line if you need to. Your final answer should be 15 u to the first power over 17. There are no negative numbers in this problem, no negative exponents in this problem, so number 24 is finished. You can put a star on number 24. It's correct. Our last problem is number 25. Spoiler alert, we're going to have to revisit this one. Your coefficient is 19 in the numerator, and it's a 1 in the denominator. We don't have to simplify the fraction. Woohoo! So we have 19 times k to the negative 10 over 1 times k to the 16th power. All you have to do with this one is use the quotient of powers property. 19k to the negative 10 minus 16. Don't forget your integer rules. Negative 10 minus 16 is negative 26. So we have 19k to the negative 26th power. And we will be revisiting this one when we go over our negative exponent rules.